Hello and welcome to this video on the first of the three methods of central tendency that we have when studying data. We're going to begin with one of the most famous ones. All three are famous, but I believe that this is the simplest one because it's the mode, and the mode is simply the value that has the highest frequency. So in this case, we're given just a small example for us to deal with. It's like, okay, imagine we're rolling 25 rolls on a die, and we are looking for all the times that each value shows. In this case, there were 5 ones, 6 twos, 5 threes, 3 fours, 2 fives, and 4 six. It is quite straightforward to see that the mode is 2 because it has the highest frequency. There's something that we need to remember before we deal into something a bit more complicated. That is that a set of data may have more than one mode, or it could have no mode at all. If all the values have the same frequency, then we say that there is no mode, and that's fine. It's part of the analysis. Now, the key thing we're going to add now when discussing mode is what happens when we have grouped data, and in particular we're going to focus on a concept that we dealt when we discussed histograms. So if you want, you can look at it again. Is the concept of frequency density. When we have grouped data, we cannot see the raw values, and we're not going to find the mode. We're going to find the modal class. What is the modal class? The modal class is the class that has the highest value for the frequency density. Okay, so for example, we're going to look at our first workout here. We're going to include some exercises within these slides. So let's see if we can find the modal class of these 270 pencil lengths that are given to the nearest centimeter. What does that mean? It means that we have data that has been rounded, so we need to work with this actual classes and not the real classes. So let's take a look at this. We're going to begin by analyzing how this data works. So actually, the class for 4 to 7, I'm going to write that down, the class for 4 to 7 is not for 4 to 7, it's actually from 3.5 up to 7.5 because data is rounded, so we must consider that. And then the amplitude, I'm going to write it A to be the amplitude, is 4 because this is the actual class, and here A stands for amplitude. So we have that actually there are 4 centimeters between the lowest, the upper boundary and the lowest boundary. Then the class for 8 to 10 is actually from 7.5 up to 10.5, so it has an amplitude of 3. And then finally, the class that is from 11 to 12 is actually from 10.5 up to 12.5, so it has an amplitude of 2. So then remember that the frequency density, that is just equal to the frequency over the amplitude, in this case is going to be 100 over 4, that's going to be 25, then it's going to be 90 over 3, it's going to be 30, and then it's going to be 80 over 2, it's going to be 40. So the modal class is actually the class of 11 to 12. That's the modal class. Why is that? Well, it's because it has the highest frequency density. Although the value for the frequency is the lowest, the frequency density is the highest. That's because it's a shorter amplitude. It has a smaller amplitude, but in this case, the frequency density was bigger. So that's the modal class. The modal class in this exercise is from 11 to 12. The last thing we need to consider about all three measures of central tendency that we're going to be working with is both the advantages and the disadvantages. This is because we're going to use one or the other depending on the scenario. So about the mode, what can we say? We can say that The mode is unlikely to be affected by extreme values. It is useful. It is actually very useful because it talks about majority and talks about popularity, and we can use it for any kind of group of data. It doesn't matter if it's quantitative, qualitative. Those are like the big three advantages, and then we have disadvantages like that it ignores values. It's one data that we don't use it later on, and well, as we mentioned at the beginning, it could be not unique. In mathematics we care about things being unique, so not being unique is a problem, and well, it could not even exist, and that's a bigger problem. Another thing that we can do with the mode that I skipped there, but I'm going to go back now, is that we can work with ratios. For example, in this exercise that we have here. Here we are given that there are two classes of data. These classes of data have a ratio from 3 to 2 in their widths. Okay, this is like the data, it has the ratio in the width of 3 to 2. And we are told that there is no modal class. There is no modal class. This means that the frequency densities of these two classes are the same. So we are told the frequency of the first class, and we have to find the frequency of the second one. And this is quite simple because we can say, okay, so the ratio in the width is 3 to 2, okay? And then the frequency density is the ratio between the frequency and the amplitude. So here we have the ratio of the amplitudes. So we can say that as there is no modal class, these ratios are going to be the same. So we can say that these ratios are going to be equal to the 48 and x. Okay, here we are assuming that first class is the one with the 3 and it's the one that corresponds to the 3 and so on. It's like, okay, we're making like this assumption that is considerably is understandable from the task. So we have that the ratio between frequencies is the same as the ratio between the amplitudes. This is because there is no modal class. How can we express this in terms of an operation? Well, we can say that the ratio 48 over x is equal to the ratio of 3 over 2. And from here we can solve that the value for x, that is the frequency that we're looking for, is the product of 48 times 2 over 3, and this gives us a beautiful 32. So that's the actual frequency of the second class. Here, if we were to calculate 48 divided over 3, we will get the same as 32 divided over 2. So this is why here we have no modal class in this exercise. In case you're not familiar with notation on ratios, practice it because it may occur and it may appear in this kind of exercises. And well, this keywords on no modal class. No modal class means equal frequency density. Okay, so from there you can work on it.